In this video, I'll be covering question 4, part C from the 2018 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. Alright, so looking at part C here, they're telling us that they want us to use a trapezoidal sum with 4 subintervals, indicated by the table above, as they usually do, to approximate. This is the key on this one that kind of threw a lot of people, I think, is they want this to be the average height. So we're not looking to get the total height here of the tree, which is normally where you would just do a standard integral process, a standard trapezoidal sum process. This one wants the average. And so when you need to find the average value is an integral formula that looks like 1 over b minus a times the integral from a to b of whatever that function is, dx. So most people go ahead and do their trapezoidal sum on this that approximates that integral piece right there, but they forget that this is an average problem, and because of that, we're going to end up multiplying that final answer by this fraction out in front. So for this specific problem, what we would be setting up, there's the interval they care about, so that's going to be our a value and that's going to be our b value. So we'd be setting up the integral from 2 to 10 of, and then this time it's our height equation, so h of t dt, but we're going to multiply that by 1/8. So we're still going to use that trapezoidal sum process to approximate this, but to get our final answer, we're going to end up multiplying it by 1/8. So when I'm doing any Riemann sums, trapezoidal sums, and I have a table of values that I'm working from, I usually just pull that table of values onto a number line. For me, it makes it much easier to digest. There's certain times on a test where if you can make the information easier to digest, it works out better in the long run. So the first thing I do is I lay out what would normally be thought of as the x values on that number line. So this would be 2, 3, 5, 7, and then the last gap here would be 10. And then I come back in and I put the y values that would be with each of those x values right above them. So with 2 would go 1.5, with 3 would go 2, with 5 I would put 6, with 7 I would put 11, and with 10 I would put 15. And then I come back through and I lay out, I just call that area 1, area 2, area 3, area 4. And that tells me that I've broken it up properly because that area 4 is telling me that I have 4 subintervals. And then I just kind of put these things all together as little individual math problems. So area 1 equals, area 2 equals, area 3 equals, and then area 4 equals. And then I'll add those things up to get the approximation for that integral right there. This is a trapezoidal sum. So when we're doing trapezoidal sums, the trapezoidal sum rule, the area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. And so when you think about that in terms of a normal trapezoid, base 1 is down here, base 2 is up there, and then your height goes here. Well, when we're doing these Riemann sum problems, what you're essentially doing is you're rotating this same shape up onto its side here. And so now base 1 is on this side, base 2 is on that side, and the height is right here. So what we're going to see is that these bases now, these are going to come from the y values because these are the up and down pieces. And that h there, that's going to come from what you would normally think about as your delta x. So we start putting this formula together. So this would be 1/2 base 1 plus base 2 times the height. And so I just call this sort of my assembly line process. I'm going to go 1/2, 1/2, 1/2, 1/2. And now inside here, I'm going to go ahead and go grab those base values. So on A1, my first base is the left side, which would be 1.5, plus my second side would be 2. And then as I go to A2, my first side would be 2, my second base would be 6. I go to A3, my first side would be 6, my other base would be 11, and then on A4, my first base would be 11, and my second base would be 15. And that's why I like working off of the number line instead of the table. It's just easier for me to digest that material really quick and easy. So now what we need is we need the h. Well, remember that the h is now this gap here. It's our delta x on each of these, or delta t, I guess, in this specific situation. And when you pull that data off of the table and put it onto the number line, I also think it's easier to see that these gaps change. The gap on that first one is 1. The gap on this second one here is 2. The gap on this third one here is still 2. And then the gap down here is 3. When they use a table, they like to switch up. So a lot of your problems you probably practiced with had a standardized gap. And remember that off of a table, they can break that up however they want. So just be careful there. So then this is going to be, the height for A1 is 1. The height for A2 would be 2. The height for A3 would be 2. The height for A4 would be 3. And so then I go solve those, multiply those things out, and see what I get. So then A2, I'm going to have 3.5 times a half. So 3.5 over 2. On the next one, I'm going to have 8 times a half. So 8 from here times a half is 4. 4 times 2 is 8. Then on the next one, I would do 17 times a half is going to get me 8.5, and then that times 2 would end up giving me 17 out of there. Or you could do 17 times 2 is 34, or cancel those 2's out, however you want to do it. That gets you 17. Then on the last one, we get 26 divided by 2 or multiplied by a half is going to get us 13. 13 times 3 is going to get us 39. So then we add up all of that stuff right there to get out what just the front part of this is going to be equal to. So then from there we would get 3.5 divided by 2. You might want to think about that as 1.75. Then 8 plus 17 is 25. Then I've got 39 here. So then putting those together would get me 64, and then adding that to the 1.75, I get 65.75. And that's just the front side of this. So right now what I have out is I've got the integral from 2 to 10 of h of t dt is approximately 65.75. And now my last move here is I need to go ahead and just multiply that by the 1/8 from up above. So then that's going to be times 1/8. So I'm going to get 1/8 times 65.75, which I would just write as 65.75 over 8, since they don't give us a calculator to use on this section. And then you just always remember what your units are on this. So this is going to be meters, because we're still talking our y values, our h values right there. And so this is the average height of a tree, the approximate, I guess you might want to say, the approximate average height of the tree in that interval. So from t equals 2 to t equals 10. And you're done. So this problem would have been 2 points. You would have gotten a whole point from doing all of that work right there on your trapezoidal sum setup, and then getting out the final answer. And then you would have gotten another point for multiplying that by 1/8 and coming up with the final answer here. So 2 points total. Just make sure, be careful on these, right? Don't move too fast. Look out for words like average to let you know that you've got to do a little bit more than just your normal trapezoidal sum. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.